I want to do something special today. I want to remake a tutorial, but not any tutorial. I want to remake the very first one I did for Entagma, which is the Ender's Blossom setup. Why does it need a remake? Well, it's still a surprisingly popular tutorial, but Houdini has progressed quite a bit, and also I have become quite a bit better at explaining stuff. So I think it's due for an update. The general structure will still be the same. We're going to model a single petal, animate it, then copy it a bunch of times to create a blossom, simulate that, and turn the whole thing into an endless loop. So first of all, inside an empty scene, let's drop down a geonode, let's dive inside, and let's build our single petal. And for this, I want to actually abuse the Houdini feather system, because as it turns out, it can create quite nice flower petals as well. So for this, I'm going to start out by searching for a feather template, and I'm going to use this template preset in here. This is going to lay down a bunch of nodes for me, and what I mainly care about here is the first curve node, where I can define the main shape of my flower petal. So for this, I don't want to use this curve right here. I'm going to bring in some curves that I created earlier. This is these curves right here for a general shape, and then also this curve right here for the sort of barb structure. And I'm just going to get rid of this curve right here and then connect this curve to this. And now this is my new petal shape. Now currently on this petal we have way too many divisions for a flower petal. So what I'm actually going to do is I'm going to drop down a feather resample node, and I want to resample both the shaft and the barbs. And for the shaft I'm going to take a value of 30, and for the barbs a value of 12, like this. Then next I want to add a bit of noise to my petal. So for this, let's actually use a feather noise node. I'm going to start out with some large scale noise, and the only thing that I'm going to change in here is the amplitude, and I'm just going to turn it up to around 0.02. And if you now take a look at a feather from the profile, we can see a bit of unevenness in there, which is exactly what we want. Then I also want to add some high frequency noise, so let's copy this one more time, write it down below. And here I want to set the amplitude to 0.03, but I also want to up the frequencies down here quite a bit. So let's up the shaft frequency to a value of say 6.5, and then also the barb frequency to a value of 10, like this. And this currently affects our entire petal like this. However, I just want to have it on like the upper end. So what I can do to fix this is I can enable a ramp on my amplitude, then shift this range in here back a bit. Let's also create some new points in the middle, and let's also select all of the points in here and turn them into a Bezier interpolation. And then let's just work on the shape of a curve in here a bit, and I think this is looking fine. Something like this. So with this, I can then turn it into an actual mesh, and I can do this with a feather surface node. And just like this, we have a nice looking petal and also some nice looking UVs already on that petal. The only thing that's annoying me here a bit is this stem part down here. So to get rid of this, I can go to surface down here and to shaft output and change this from surface to none, and now I have just a single petal. And as the very last step, I want to drop down a normal node, wire this down, set the cusp angle to 180 degrees, make it nice and smooth, and now this is my entire petal done. So let's make the node tree a bit more orderly, and since this is going to be a big setup, I also want to color code my nodes, and I want to color code this part in a nice teal. Now with this done, next I want to animate my single petal, and I could use bandstops here like in the original tutorial. This is still a valid way. However, nowadays Houdini also has kin effects, and I'm quite a fan of kin effects, so let's see if I can use it in here. So I have to find some way to turn my petal in here also into a kin effects rig. And I think I can do that quite easily by branching out in here from my noise node, because what I can do now is I could use a feather uncondensed node and write it up like this. Branch out from my feather noise, and this will turn my feather in here into a bunch of polylines like this, which already look very much like a kin effects rig. So we're on the right track here. Now kin effects is particular about its attributes, and we need a transform attribute, and for this we can use an orientation along curve sub. Now the transform attribute that kin effects wants is not an up vector and a normal vector. It wants to use a 3x3 transform matrix called transform. So we can just select this in here, and this worked best for me if I set the target up vector simply to the y-axis, to the axis perpendicular to all my petal. And also currently those barb segments aren't connected to the shaft yet, so let's fix this simply with a fuse node, and let's simply wire this down below. And then I also, for animating, want to make sure that I have a point group on my main shaft in here. So for this, let's make sure that we have a group. For this I can go to the feather uncondensed node, go to output groups, and enable a shaft group like this. However, this is currently on primitive level and it's just sort of the main single curve right here down the middle. So what I want to do next is I want to promote it to point level. So for this, let's drop down a group promote, wire this down and convert our shaft group to point level. And now it's running along a main shaft in here. And to turn this into a kinefix rig, let's fix the rest of our attributes. And we can do this simply by using a rig doctor. And now this is actually a perfectly fine rig inside of Houdini. So now what we can finally do is we can take our main petal and capture it to our rig. For this, I'm going to use the simple setup. I'm going to use a capture by proximity node, bone capture proximity like this. And our main petal goes into the first input and our rig goes into the second input. And this is actually everything that we need to do in here. And then to animate it, we're going to need a bone deform node and our main capture petal will go into the first input. Our static rig will go into the second input. And now on the third input, we can put in a deformed rig and animate our petal this way. And for this, I'm going to use some rig pose nodes. So that's right in here under our rig doctor. And on the rig pose nodes, I want to set up 4 point groups for 4 different animations or 4 different parts of my petal that I want to animate. So let's hit this transformation button in here 4 times. And the first group that I want to set up, this is simply going to be the first point in our rig, this point 0, and hit accept in here. And if I wire this down into my bone deform and see what the output is, and let's say adjust the scale, with this I can adjust the entire scale of my entire geometry. Then the next group that I want to set up is the shaft. Just enter the name of a point group, a shaft group in here. And what I can do with this, if I, for example, rotate it around the x-axis, I can make my petal curl up. So this is also going to be quite important for our animation here. Then our third group should be everything but the shaft. So let's write just exclamation point shaft. And with this, well, if I rotate around the x-axis, I can curl my petal along those barbs like this. And the very last group, this is a group that I want to set up manually, is I just want to select part of the shaft, the upper part of the shaft. So select those points manually in here. And I mainly care about the upper half of my shaft in here. So let's select it like this and hit enter. And then with this section, I can make my shaft curl up or down just on this top section. So with this prep work done, I can actually work on the poses for my flower petal. I want to have 2 poses. So let's copy it one more time and let's work on the first pose. I want to set the entire scale of my petal to be half as big. So let's set it to 0.5. Then I also want to have it entirely curled up. So let's set the value in here to say -12. And I also want to curl it up along my barb direction. So let's also set it to, in this case, -11 in here. And there's some weirdness happening here on the sides. And I can get rid of this by slowly bringing down the scale. And I think if I bring it down to around 0.85, this is now completely fixed. And actually with the last value, I want to do nothing for now. I just want to tweak this on the second pose. So let's work on that second pose. What I want to do in here is I don't want to change the scale, but I want to move it out just a tiny bit, just 0.1 units in the Z direction. Then I want to curl it up just a tiny bit. So on the shaft group, let's set this to maybe -1.2. Let's do the same for our barbs as well, -1.2. But let's also use the last group to curl it just a bit into the other direction as well. Set the X rotation here to 7.5. And I think this is a really nice pose for a petal in here. So what I can do is I can drop down a pose blend node or a skeleton blend, and I can use this to blend between my 2 poses. So right up like this, and now I have this single slider. And with that single slider, I can do the entire opening animation of my one flower petal. So let's actually animate this, make sure we're on frame 1. Let's add a keyframe in here at 0 and move on to frame 96. Set the weight to 1 and add another keyframe in here. And now this is my opening animation. Clean this part up as well and let's color code it as well. So this is my single petal animation. And now let's actually turn a petal into a blossom. And for this, I want to make copies of each petal. I want to rotate each petal a certain number of degrees. And then I also want to time offset each petal. And this in the end will create my blossom animation. So to actually do this, I'm going to need a for loop. And I'm going to start out with a for loop with feedback. This will be just a base. I want to make some changes to this. On the repeat end, I want to set the iterations to 20. And I want to set the gather method to merge each iteration. So each loop iteration will mean there's a new petal in our blossom. Then I want to work on the for each begin. And in here, I want to set the method from fetch feedback to fetch input. So for every loop iteration, a loop in here will just grab the output from this node above here. And we can actually wire this in here now. And then finally, I also want to be able to grab the current loops iteration iteration. And I can do this by creating a meta import node, by hitting this button right here. And on this node, if we cook it and take a look at the attributes, and I think we have to cook the end right here. Yeah, right here we have a detail attribute called iteration, and this is the current loops iteration. Let's also make the file name in here a bit shorter, or the node name, just call it MD for metadata. Now what I want to do inside the loop is, again, rotate each petal. And you can do this with a transform stopper. And I want to rotate each petal around its y-axis, so the vertical axis, and I want to rotate each petal a multiple of 137.5 degrees, so the golden angle, quite useful for flowers. Now to actually rotate it, one step for each iteration, I have to get access to my iteration, so it's multiplied, and my iteration is going to be a detail attribute. I have to grab the right geostream, so for this let's start out by writing a string, then write 2 colons to jump out of this node, then a slash, then we can select our MD node like this, our metadata node, and this is our geostream done. Then we want to grab the right attribute on here, and this is called iteration. And then, even though we're dealing just with a single integer, we have to grab the right component of that attribute, and in this case it's just going to be 0. And as soon as we do this, we see we have a lot more petals in here. One other thing that I also want to do in here is with each iteration, I want to move each petal down a bit to just prevent some intersections. So for this, I'm just going to copy the whole expression in here. I'm just going to paste it into the Y translation axis up here. And I'm just going to decrease the value right here in the front to 0.005. And now we have a bit of a gap between each flower petal, which is exactly what we want. Now let's also work on time offsetting this. So for this, I'm going to use a time shift node, where this below our transform node. And the expression is going to be quite similar. So I'm just going to jump back to my transform node, and I'm just going to copy all of this right here. So back to my time shift node. And what I want to do in here is I want to take my frame, subtract my current loops iteration like this, multiplied by some constant, let's say 4 frames, like this. And what we're seeing now is something that already looks a lot more like a flower blossom. To actually shape this flower blossom into something that looks a bit more beautiful, I can jump to frame 96, the end of the first animation of the first petal, and I can actually go back up to my skeleton blend up here and hit V on my keyboard to bring up the animation curves. And I can actually treat these animation curves as a way to shape my flower blossom. So what I can actually do in here is, for example, shape a curve into something that looks a bit more like this and a bit more like this. And then maybe also bring down the end level of my animation a bit, something like this. Yeah, and I think this is a nice looking flower blossom in the end. And also, if I now scrub in my timeline, I have this beautiful animation in here of my flower opening. So we're done with this part of our setup. Let's also color code it. So this is our flower blossom. And now I can actually work on simulating my flower petals falling down. What I want to do for this is I want to just simulate 10 petals falling down. So let's decrease the iterations back down to 10. We're going to add those missing petals in here later. And now I have to do some prep work for my simulation. Because what I want to do in the end is I want to have every petal in my flower blossom to follow its animation until it reaches its end frame. So for a first petal, frame 96, for a second petal, frame 100, and so on and so forth. And as soon as they reach this frame right here, I want to add them to a Vellum simulation. So what I want to do first is I want to create 2 point groups. One point group that tells which petal is still in its animation state, and another point group that just blinks on for 1 frame when one petal is at the end of its animation state. So let's set this up. I want to set this up before my main for loop that creates a blossom. And I want to use mainly a point wrangle for this. So on this point wrangle, I want to have some way to specify the end frame of my animation. And I want to store this in an integer variable called ef for end frame. And this should be simply an integer slider, which I can create with this channel integer expression right here. And let's also give it a name. And let's call it end frame like this. Let's create that slider. We put this end frame at frame 96 like this. And then from this end frame, I want to create 2 groups. The first one will be if we're still in the animation state. So I add group anim, and this is how you can quickly create a group of X. And in here, what we want to check is if our current frame, so add frame, smaller than end frame like this. And then let's create another group, and let's call this Vellum source. And again, group underscore in the beginning. And in here, we want to check if our current frame is actually exactly our end frame. So add frame is double equals to F, like this. Now this currently looks a bit confusing. To actually make this a bit clearer, I want to visualize it. So to visualize it, I want to drop down 2 color nodes. And on the first color node, I just want to color everything that's in the anim group. And let's color this pink. So as long as we're before frame 96, this is pink, and after it, it's gray. And then I simply want to copy this one more time and color the Vellum source group and color this a dark purple. And this is only active on frame 96. After that, it's just gray. And if we're before that, we're just in the anim state. Currently, this is not doing much. However, if we take a look at the end of our loop output, as we can see when we're starting out, every petal is pink. However, as soon as we start going over this frame 96, some petals will become purple, and let's also maybe get rid of this two-sided shading in here, so it's a bit more obvious. And other petals will become gray, which means they're completely done with everything that they need to do. So with this done and with this prepped, what I next want to do is I want to bring my flower blossom to the right position where I actually want to simulate it. And for this, I want to bring in another curve that I drew earlier, which will be the shaft of my flower, or the stem. And this is this stem right here. And I just want to copy my entire flower blossom onto the end of this curve. So to do this, I need to turn this spline right here into a polygon curve. So let's use a resample node for this, and the defaults are fine. And I'm also going to need an orientation attribute on there. So let's use the orientation along curve here as well. And with this, the defaults are actually fine. And what I now finally can do is I can drop down a copy to points, wherein the output of my for loop into the first input. And before I wire in the second input, I should restrict this just to the endpoint. So let's just add a 0 in here on target points, and then wire in my orientation on a curve. And now my flower petal is right at the end of my curve in here. If it happens to be at the other end, this is quite a simple fix. The only thing that we need to do in here is add in a reverse node, and add in the reverse node after a curve node and before resample. And now it's at the right location. However, in this case, this is fine. Let's disable this. And the other problem that we need to fix is that the flower head is rotated. So to fix this, I'm going to simply use a transform node, rotate it minus 90 degrees on the x-axis, and now it's pointing the right way up. So with this done, I can set up my Vellum simulation. And again, I want to add each petal to my Vellum simulation as soon as it's at the end of its animation. So as soon as it's in this Vellum source group. So what I can actually do in here is drop down a blast node, and in here blast everything away but a Vellum source group. And if I scrub through my timeline, we have now these single frames where just one petal just blinks into existence, like this or like this. And as soon as it blinks into existence, I want to add it to my Vellum simulation. So to do this, I have to convert it into a Vellum object, into a Vellum cloth object. So let's drop this down, Vellum configure cloth. And the only thing that I want to change in here is the bend stiffness. And I actually want to set it quite a bit higher because flower petals are quite a bit stiffer. So let's set this to 100, for example. And then what I'm going to do is I'm not going to wire it into a Vellum solver, but instead I'm going to set up two nulls, two reference nulls, both for my main geometry and then also my constraint geometry like this. And what I can then do with both of those nulls is I can finally drop down a Vellum solver. On this Vellum solver, to make it happy, I just want to drop down one other null connected to nothing and write up to the first inputs so we don't get an error anymore. And then on this Vellum solver, I want to jump inside and I want to search for Vellum source, wire it into the source output in here as well. And then on the Vellum source node, I have two SOP import paths in here. I can first specify my main geostream or main geonull in here, and then also down here my constraint geonull, like this. And now with this entire strange setup done, what I can do now is play my animation like usual, and this should work. It does not. Let's see where I missed out, what I missed in here. And it's the emission type, and I have to set this to each frame like this. So now if I play my animation, for the most part, nothing happens. However, as soon as we start hitting those frames where we also have a Vellum source group set, now these petals are going to be added to a Vellum simulation in here, and they're going to fall down. And actually, to make this a bit more sensible, what I can also do is I can copy my blast node in here, and in here delete not everything but a Vellum source group, but everything but our anim group. So like this. And then below our solver, I can drop down a merge, and I can merge the output of this blast node with the output of our solver. And now this entire trick is complete. So every petal completes its animation and then gets added to our Vellum solver. So we're pretty much done with our simulation in here. Just a couple of tweaks that I want to make in here on my Vellum solver. Currently, I think the petals are falling down a bit too fast. So let's bring down the timescale to 0.5, make them half as fast. And also, since we're dealing with quite stiff petals, I have to up the constraint iterations to say 300, because this gives just more accurate results for stiff pieces of cloth. And then under the forces tab, I want to add a bit of wind. So let's set the built-in wind direction to these values right here. And then also the wind speed to 3 like this. And then what I also want to do is I also want to bring in my shaft right here as a collision object. So from my shaft up here, I want to make it a bit shorter, and I can use a carve node for this. And by making it shorter, I'm just ensuring, and let's also not adjust the first U, but the second U. Nope, the first U is the right one. Just have to get rid of this ghosting in here. I just have to make sure that my petals aren't intersecting with the tip of my shaft. So let's set this maybe to 0.035 like this. And then I also want to sweep it to give it some actual geometry. And I'll just set the surface shape to a round tube. And set the radius to 0.05. And I want to add end caps. I want to add them as a grid. So we get this nice dome shape in here. And then this finally can go into our Vellum solver, into the collision input like this. And then we can finally play our simulation. And what I mainly want to watch out for here is that all my petals are sort of exiting the frame that I'm imagining for my camera. So let's see. Around frame 175 looks good to me. So what I am able to do now is actually cache everything out. So let's drop down a file cache node. And here set the file path to explicit. I just like this a bit more. And let's tweak the start and end range. And I want to set the end to frame 175 like this. And let's hit save to disk on there. And after a bit of waiting, we now have a simulation cached out and nice and fast in our viewport. This is our entire simulation part, so let's color code this as well. Let's maybe grab a nice pink color. And now we're almost at the end of our setup. The very last thing that we need to do is we want to make copies of our flower and offset these copies in time to actually create a looping animation in the end. And if we're creating copies and offsetting them in time, well, we already have a perfectly fine working setup up here. So let's just grab this, hit copy and hit paste the entire for loop. Let's write it below our file cache in here. Now we can get rid of the transform node in here. We don't need it at the moment. The only thing that we have to set in here is how many copies we want to create. And I think 10 for this is a bit much. Decrease it to 5. And we have to find out how much we want to time offset each iteration of our loop. So how much do we want to offset each loop? Well, in our first setup, in our first loop, we put a time offset of 4 frames onto every iteration. And we had 10 iterations, so 40 frames in total. And we just want to add one more iteration on top of that. So in the end, 44 frames. This is the entire time offset of one iteration of a looping animation in the end. Let's write 44 in here. And also in this case, I don't want to shift them forward in time by subtracting, but I want to shift them backwards in time by adding this value to it. So something like this. And now, if I jump to the end of my loop, I now have a complete flower blossom again. Let's also make this a bit more orderly. And if I jump to the very first frame, and if I make the length of my timeline as long as this time offset right here, so 44 frames, I should have a perfect looping animation in the end. And let's give this a try. And yes, this looks good. I can still see some jumps down here, so to get rid of them, that's quite easy. Just increase our loop iterations like this. And I think we're hitting the end of our simulation here. So with this, I can either simulate the file cache for longer or just simply adjust the view through my camera so that we don't see this jump in here. And now we have a perfectly looping animation of a blossoming flower. This is where I'm going to leave this for today. I'm just going to get back through my setup and tweak it a bit, make it look a bit more nice. And then in the next episode, I think we should talk about shading this flower, about creating some nice procedural textures using Copernicus, and then putting this all into Karma to shade it there. But this is it for today. And until next time, it's cheers and goodbye. And if you like what we're doing, please consider becoming a patron of ours, not only for supporting Entagma, but also for access to in-depth courses, like for example our KineFX course, which goes into much more detail about the system that I quickly showed at the beginning of this setup that we built right here. And actually also in this course we have a setup for a giant rigged flower that can do much more than this thing that we built right here. So if you're interested in that, check out this course. And also let me say thank you so much to all our existing patrons. Without you, this channel could not be possible. Thank you.